You know that feeling when you're standing on a train platform and an express train just whips right past you?
Oh, yeah. The wind knocks you back. The sound is completely deafening.
Right, and by the time you realize what just happened, all you see are the taillights just disappearing down the tracks. Well, welcome to the deep dive.
Because if you're standing on that platform right now, just watching the rapid rise of artificial intelligence and wondering how to catch up.
Yeah, without feeling completely overwhelmed, right? You are in the exact right place.
Yeah.
Because we're looking at this ecosystem that went from, clunky, frustrating website chatbots to massively complex agents, basically overnight.
It really is disorienting, and that feeling is entirely justified, even for people who are, entrenched in the tech industry. The landscape shifts almost daily.
Which is exactly why we've pulled together a massive stack of sources for today's mission. We're looking at university ethics guides, technical documentation straight from IBM.
We also have beginner course curriculums from Free Academy and the University of San Diego, plus detailed YouTube tutorials and these really comprehensive overviews from Sumo Logic and Tableau.
So our goal today is to really cut through the noise and give you a complete fast start roadmap to ramp up quickly on AI. And spoiler alert, you absolutely do not need a computer science degree to do this.
No, not at all. And we're not just looking at one single provider either. We are looking at the whole ecosystem.
Right. So tools like ChatGPT, Claude, Perplexity, Gemini, and Grok. We want to figure out exactly how these tools work under the hood and, how you can actually master them.
Because understanding the underlying mechanics, it fundamentally changes your relationship with these systems. You stop treating them like magic boxes.
Right, and you start treating them like the highly tuned statistical engines they actually are. But before we start playing with the tools, we kind of need to quickly de-jargonize the AI umbrella, right?
Yeah, we definitely do, because these terms just get thrown around interchangeably at dinner parties, in boardrooms, everywhere.
So, based on the Sumo Logic and IBM sources, I really like this Russian nesting doll analogy.
Oh, that's a great way to look at it.
Yeah, so the biggest, outermost doll is artificial intelligence. It's this broad, 100-year-old concept coined way back in 1956. It basically just means machines mimicking human cognition.
Right, and then you open that outer doll, and inside is machine learning, or ML. For decades, software was strictly rules-based.
Like a programmer explicitly typing out, if this happens, do that.
Exactly. But machine learning abandoned the explicit rules and moved to statistical probability. You feed the computer a massive data set, and it just finds the mathematical patterns on its own.
Okay, so then inside the machine learning doll, we find deep learning, which utilizes artificial neural networks. And the deep part just refers to multiple layers of processing, right?
Yeah, precisely. The system refines and abstracts information as it passes through each of those layers. This is actually what made advanced image recognition and self-driving cars possible.
Which brings us to the smallest, but definitely the loudest nesting doll right now. Generative AI and large language models, or LLMs.
And the crucial shift here is from classification to creation. Traditional ML was about sorting data.
Like deciding if an email is spam or not.
Right. But generative AI creates net new data that mimics human output. And for text generation, LLMs rely on an architecture called a transformer.
And this is where the IBM documentation gets super fascinating to me. An LLM doesn't actually, know facts. It doesn't reference some giant database of truth.
No, not at all. It ingests billions of words, chops them into smaller machine-readable fragments called tokens, and maps them into a massive multidimensional vector space.
So it's essentially plotting words on a giant mathematical graph based on their relationships. Like the words dog and bark are given coordinates very close to each other in that vector space.
Exactly. Whereas tree and bark are clustered differently based on their context. That spatial mapping is the core mechanism. Yeah, and the real breakthrough of the transformer architecture is a function called self-attention. Instead of reading a sentence word by word from left to right, self-attention allows the model to look at the entire sequence simultaneously.
So it weighs the relationships between every single token, regardless of how far apart they are in the paragraph.
Right, that's how it grasps context. But at the end of the day, when you ask it a question, it is literally just calculating distances in that vector space to predict the most mathematically probable next word over and over again.
Okay, let's unpack this, because this brings up a huge question for me. If all these tools, ChatGPT, Anthropic's Claude, Google's Gemini, Grok, Meta's Llama, if they're all just predicting the next word based on a giant vector graph of internet data, aren't they basically all the same tool with different logos?
I hear that all the time.
I mean, it feels like we're just looking at different flavors of vanilla.
It's a really common assumption, but the underlying internet data is just the raw material. The real engineering nuances happen in how those models are refined and aligned.
Because you can't just unleash a raw internet-trained model on the public.
Exactly. It would just spit out chaotic, unfiltered internet noise. So the differentiation happens during fine-tuning.
Which involves a massive amount of human intervention. The sources detail this thing called RLHF reinforcement, learning from human feedback.
Yeah, where human testers are essentially giving the AI a digital thumbs up or thumbs down, ranking its responses.
So it's kind of like behavioral conditioning for algorithms.
Hmm.
The model literally learns to adjust its probabilistic weights to favor outputs that humans actually find helpful or safe.
Precisely. And then you layer on instruction tuning. A raw model doesn't know what a summary is or how to be an assistant.
Right.
So instruction tuning feeds the model thousands of specific prompt and response pairs, so it learns the cadence of a conversation and the formatting of a helpful answer.
So that human feedback loop is what gives each AI its distinct personality, or what the industry calls stylistic alignment.
That's exactly it. That explains why Claude often feels more cautious and highly analytical, whereas Grok is explicitly tuned to be more colloquial, rebellious, and even humorous.
And then you have tools like Perplexity, which take that conversational model and sort of wrap it around a live search architecture, which changes the interface entirely.
Yeah, Perplexity is a great example of applying the model differently, and the foundational architectures are also starting to diverge now.
Oh, really? How so?
Well, transformers are the standard, but newer models are experimenting with architectures like Mamba, which process long sequences of text far more efficiently without needing to weigh every single word simultaneously.
Interesting.
We're also seeing the rise of dedicated reasoning models. These are forced to break complex logic problems down into visible, multi-step thought processes before generating an answer. They don't just predict the next word, they predict the next logical step.
Okay, so we have this diverse ecosystem of highly tuned thinking machines. But if someone listening wants to actually start using them today, the University of San Diego roadmap and those free academy courses point out a massive misconception.
Let me guess that you need to know how to code.
Yes, you absolutely do not need to know how to code. The most encouraging stat from the source is that 70% of AI professionals in 2025 did not come from a computer science background.
Wow, 70%.
Yeah, they came from marketing, business design.
Basically, fields rooted in communication and problem solving. Working with modern AI is much more about articulating constraints clearly, not writing syntax.
Exactly. And the Fast Start roadmap suggests starting with foundational literacy, so like taking an AI Essentials course or Andrew Ng's AI, for everyone just to understand the concept.
But passive learning hits a wall very quickly. You have to get your hands dirty.
Right. The YouTube tutorial sources stress that you really learn by experimenting, by finding the edges of what the tool can actually do.
The recommendation is to break your learning into practical chunks. Like, week 1 is prompt engineering, week 2 is image generation, week 3 is data analysis.
And for that first week, the sources outline a 6-part prompt formula that entirely moves you away from treating the AI like a Google search bar.
Which is critical. It forces you to treat the AI as a collaborative intelligence. The 6 parts are task, context, intent, persona, format, and tone.
I love the example they gave for this because it makes it so clear. If you just type, "Give me a travel guide for the Caribbean," the AI defaults to the most generic, highly probable response.
It's just boring.
It's super boring. But using the formula, you structure it completely differently. You say, act as the pirate Jack Sparrow. That's your persona. Write a travel guide. That's the task.
Right.
For 3 islands in the Caribbean context. To convince people to go on an adventure intent, make it exciting and humorous tone,
Right.
and format it in exactly 200 words.
And the output generated from that highly constrained prompt is immediately usable and deeply customized. You are no longer just searching for an existing document.
No, you are providing a brief to a digital thinking partner that is generating novel solutions based on your parameters.
And once you nail that kind of communication, you can actually break the AI out of the text box entirely. The ChatGPT tutorials walk through power user features that move these systems from passive text generators to active, multimodal workflows.
Because, we've mastered typing, but human communication is highly visual. What happens when we let these models actually see?
That's the vision feature. And honestly, the mechanism behind it is brilliant. When you upload a photo, say an Instagram picture of a complex meal like ratatouille, The AI doesn't just see a flat image.
It maps the pixel clusters from that image into the exact same mathematical vector space as its text tokens, doesn't it?
Yes. It reads the visual data alongside your text prompt, identifies the ingredients based on their visual coordinates, and outputs a step-by-step recipe.
That is wild. It's literally translating visual data directly into actionable text. The sources also highlight this Canvas feature, which I think is huge.
Oh, Canvas is a game changer.
Because in the past, if an AI wrote a brilliant 5-paragraph email, but you just wanted to change the tone of the third paragraph, asking it to rewrite that section usually caused it to hallucinate a completely new email, and it ruined the parts you liked.
Right, but Canvas fixes that by creating a parallel workspace. You just highlight a specific sentence in the canvas and prompt the AI to tweak just that highlighted section.
So the model isolates those tokens without disturbing the mathematical flow of the surrounding text. It becomes true collaborative editing.
And then there's voice mode, which actually analyzes your cadence, your tone, and your pauses in real time. It allows you to walk around the room having a fluid, back-and-forth verbal brainstorming session.
It feels like magic. But for sheer utility, I think the advanced data analysis feature is the absolute heaviest hitter.
I'd agree with that. Because LLMs are inherently statistical text predictors, they are notoriously bad at doing actual math.
Right.
But advanced data analysis solves this by changing the mechanism entirely. When you upload a raw, messy CSV file of financial data, the AI doesn't try to just guess the math.
Instead, it writes a custom Python script to analyze your specific data, right?
Exactly. It spins up a secure, invisible digital sandbox, executes the code, and then reads the factual output back to you, generating interactive charts in the process.
It's literally doing the work of a junior data scientist, and you never had to look at a single line of code. You can even automate these processes using scheduled tasks.
Like telling the AI to run a specific web scraping script every morning at 8 a.m. and send you a summary.
Which perfectly brings us to a massive paradigm shift. The Sumo Logic and Wikipedia sources spend a lot of time on Agentic AI.
Oh, this is where it gets really intense.
Yeah, because we are moving from an AI that just types back to us to an AI that actually pursues goals.
Agentic AI represents the bridge between a passive tool and a proactive digital agent. Instead of a single prompt and response, an agent operates on a recursive loop.
So you give it a high-level, objective-like research competitors in our local market.
Right. And the agent autonomously breaks that goal down into sequential steps. It decides to use a web browsing tool to find the competitors, uses a data scraping tool to pull their pricing, evaluates its own progress to see if it missed anything, and then compiles the final report.
So instead of manually steering the AI through each of those microtasks, you are managing it like an extra teammate. It makes decisions, executes actions, checks its work, and course corrects.
It is a massive force multiplier.
Yeah.
It is. However, as these systems gain autonomy and handle more complex multi-step workflows, the risks associated with their underlying architecture become really magnified.
Because a minor error at step 1 of an agentic loop can compound into a massive failure by step 10.
Exactly.
Which means we absolutely have to talk about the guardrails. Because relying blindly on a statistical engine is dangerous. The most glaring limitation of these models is the hallucination.
And to really understand hallucinations, we have to look back at that vector space mechanism. An LLM's core directive is to predict the next token to complete a sequence. It does not have an internal database of truth.
Think of the LLM as an incredibly eager improv comedian on stage.
I love this analogy.
Right. The fundamental rule of improv is yes and. The comedian wants to keep the scene going at all costs. If you ask the AI for a specific legal precedent or a historical date it doesn't have strong data for, saying, I don't know, breaks the scene.
It is computationally less satisfying to its core objective. So it confidently invents a plausible-sounding name or statistic just to complete the sequence.
It prioritizes mathematical fluency over factual accuracy, and this has severe real-world consequences. The Wikipedia source highlights this really crazy situation from early 2025.
The Norway story.
Yeah, where a municipality in Norway used AI to draft a report on permanently closing some local schools. The AI literally generated fictitious sources and entirely fake quotes attributed to real professors.
And the municipality just published the report without catching the ghost sources.
Right, which derailed the entire school closure process and actually led to the resignation of an official.
If the AI can invent a fake professor that confidently, it changes how we have to approach the tool entirely.
Completely. Which is why the Charlotte AI Institute put together an ethics guide for students that provides a perfect framework for anyone using these systems. Their core tenet is enhance, do not replace.
That is so important. The guide insists that you must treat generative AI output as a secondary source. It is a draft, it's not a final product.
You are using the AI to elevate your work, not bypass the work. Human critical thinking is the essential final filter.
You have to verify the output externally and ensure your specific expertise remains the driving force.
It's exactly like using a GPS. A GPS is an incredible tool that enhances your ability to navigate a new city. But if the GPS recalculates and tells you to drive your car down a flight of stairs...
You still need the critical thinking to hit the brakes.
Exactly. The AI is a powerful collaborator, but if you abdicate your responsibility to think, you are eventually going to drive down those stairs.
But if you apply that critical filter, if you use the AI to challenge your own assumptions, to speed up your routine analysis, and to explore creative angles you hadn't even considered, the leverage it provides is truly unparalleled.
It really is. Let's look at the ground we've covered today. We de-jargonized the AI umbrella, tracing it from machine learning to the deep layers of neural networks, down to the multidimensional vector spaces and self-attention mechanisms of generative AI.
We explored an ecosystem of tools, ChatGPT, Claude, Gemini, Grok, Perplexity, and saw exactly how human feedback and instruction tuning shape their distinct capabilities.
And we outlined the Fast Start roadmap, showing how the barrier to entry is communication, not coding. We broke down that 6-part prompt formula to take control of the AI's output and unpack the mechanics behind power user features like vision and advanced data analysis.
And finally, we looked at the horizon of agentic AI, balancing that incredible autonomous potential with the strict guardrails required to navigate hallucinations and maintain our own critical thinking.
The huge takeaway here is that AI isn't some distant sci-fi future. The barrier to entry right now is zero. The absolute best way to learn is to open one of these tools and start experimenting today.
The technical landscape will inevitably keep shifting, but the core human skill of collaborating with machine intelligence is permanent, which, leaves us with a really critical question to consider.
Oh, lay it on us.
As we move deeper into the era of agentic AI, where these systems autonomously plan, execute, and iterate on their own will, our most valuable human skills simply be knowing what questions to ask. Or, as these agents become increasingly proactive, will we soon find ourselves answering the questions the AI starts asking us?
Oh, wow. That is a fascinating thought to sit with. Well, if you're still standing on that train platform, it is officially time to step aboard.
Yeah.
The train is moving, but there are plenty of seats left. Go experiment, build something new, and we will catch you on the next deep dive.